Hi dear students, welcome to our class 10 mathematics series again. These videos will focus on probability and this videos is for educational purposes only. All reference and resources are used either original or royal free or under fair use for teachings. So it will covers all the important terms and definitions of probabilities. Let us see the picture here. The pictures denote that rolling a die. This is the die. So in Ludo, or I mean in die, we have 1, 2, 3, 4, 5, 6. These are the possible outcomes when we throw a die. And in tossing a coins, this is head and this is tail. So I believe that you guys will remember this. Let's go next. Okay, let us try to learn what is probabilities of an event. When we were in lower class like class 987, we have learned that probability is measure of chance and it is given by number of favorable outcomes of an event E divided by total number of outcome. So this is what we learned in previous class, but now in class 10 we will learn little bit in different way, even though the concept is the same, but the way of writing is little bit different. So let us see all the terms that we will be learning in probability. Number one, we have to know experiment. What does experiment means? An action or process which produce, when you do some action or kind of process, it will produce a well defined outcomes means results. So when you do some action you will have a results, and this is called experiment. Now example, tossing a coins. I have shown you before. When you toss a coins, the possible outcome is just head or tail. So this, when you toss a coins, you will get either head or tail. This is the experiment. Now when you roll a die, you will get the outcomes. What are the outcome? 1, 2, 3, 4, 5, and 6. Now this is what experiment is about. Let us go to random or non-deterministic experiment. So this is an experiment where all possible outcomes are known, but the exact result cannot be predicted in advance. We know that when you toss a coin, you will get head and tail, but you cannot predict that you will definitely get head, or you cannot predict that you will definitely get tail. That is what it means. Now let's take an examples. When you roll a die, you know that all the possible outcomes is 1, 2, 3, 4, 5, 6, but we cannot predict exactly. Therefore, this is called random or non-deterministic experiment. Now let's go to sample space. What do you understand by sample space? Let's see. The totality of all the possible outcomes of an experiment. Totality of what? All the possible outcomes of an experiment. Let's take an example from tossing a coins. Now, our sample space is head and tail. So these are the possible outcomes. Can you find any others possible outcome? No, only head and tails. Another example is for rolling a die. The total possible outcome is 1, 2, 3, 4, 5, 6. That's all. So if we know all the possible outcomes, we call it sample space. This is about sample space. So please remember that it is the totality of all the possible outcomes of an experiment. Now let us talk about event. What is event? Any component or subset of sample space is an event. Now, any component means, let's take an example for rolling a die. When you roll a die once, you will get either 1 or either 2 or either 3 or either 4 or either 5 or either 6. So each component, either 1, 2, this is called what? Event. Now suppose you roll a die twice. At first, suppose you get 1. Then at second, you can get either 1 again. Second roll, you can get either 2 again, 3 again, 4 again, 5 again, and 6 again. So when we combine the results, let's say at first you get 1. At second rolls, you get 2. This is also called an event. Suppose later on, you can even get 3 and 4, or even you can get 4 and 4. So these are all events. In case you have more, suppose you roll a die 3 times. Let's say we get 1, 2, and 6. So all these events, 3, 4, 5, all these are called event, or we can say this is called subset of a sample space. So it can consist of one or more outcomes. See? It says that it can consist of what? One or more outcome. So example, in rolling an even number with a die is an even example. The event is a 2, 4, 6. This is called an event. I think you're clear with event. Next, let us go to equally likely event. So this is an event. Remember, this is no more an experiment, but equally likely events mean it is an event. What kind of event? Let's see. Events are said to be equally likely if there is no valid reason to say what. One event has more chance to occur than the other. Let's take an example here. Head and tail. Can you say that when you toss a coin, head has more chance to occur than the tail? No, we cannot say. So both this head and tail has 50-50 chance of occurrence. When the outcomes have 50-50 chance of occurrence, then we call this event as equally likely event. As an example, in tossing a coin, head and tail has the same chance of occurring. So head has no favor over the tails and vice versa means tail has no favor over the head. So they have the same chance of occurring. This is about equally likely event. Next, mutually exclusive event. So what is this? This is also an event. Now these events can be two or more events. There are two or more events can be a mutually exclusive. If the happening of one foreclose the happening of all the others. In tossing a coin, if head happened, example, if head happened, then tail will not happen, so they cannot occur at the same time. When you toss a coin once, it cannot happen head and tail together. So this implies that when head has occurred, it forecloses the happening of the tail. So this kind of event is called mutually exclusive event. Remember, it is to be two or more events. So what is event? Any components or subset of sample space. Remember that. Next, let's go to independent event. So this is an event said to be independent if occurrence of one, now one is occur, let's say head is occur, does not affect the occurrence of the other or others. That means, suppose you toss a coin, so head occur. Now when you toss for the second times, does this affect the outcomes of the next toss? No. You will either get head or tail again. So suppose you get head at the first toss, so in the second toss you will get tail. It doesn't have this kind of things. So this kind of option, there is no rules like that. Therefore, independent events means even if one has been occur in the next toss, it doesn't affect the occurrence of the others. This is called independence event. Example, tossing two different coins, A and B. If A and B are independent, so these are two coins A, then we have, this is a formula, probabilities of A and B. What is the probabilities of the two coins? Suppose when you toss a coins, you get head at first in one coin, that is at coin A. Then the probabilities of head is 1 by 2. And again, when you toss a coin B, you got a probabilities of head again, which is 1 by 2. Then when you combine these two, we will get probabilities of head and head. So what is the probability? Let's see, is given by probabilities of head for the first coin, probabilities of head for the second coins. That is half into half, that means 1 by 4. This is the way. So learn this formula nicely. Probabilities of A and B is equal to probabilities of A into probabilities of B. This is about independent event. Now elementary event. This is an event. An elementary event is one which cannot be further subdivided. Just remember. It cannot be further subdivided. Let's look at an example. In tossing a coin, head and tail are elementary event. Can you subdivide this head or tail? No, we cannot subdivide. That's all. That is about elementary events. Now let's go for exhaustive set of events. This is similar with sample space. Now what is exhaustive set of events means set of events said to be exhaustive if it include what? All the possible outcomes of an experiment. So sample space also says that the totality of all the possible outcomes of an experiment. Here also it says that it includes all the possible outcomes of the experiment. Let's take an example. In rolling a die, the events 1, 2, 3, 4, 5, 6 are exhaustive. Suppose if you write only 1, 2, 3, 4, and 5. That means it is not exhaustive. Still, you need another, that is 6. Therefore, it should have all the possible outcomes in exhaustive set of events. You have to learn properly all this. Then favorable outcomes. What is favorable outcomes? That's it. For every experiment, any experiment like tossing a coin, out of the set of exhaustive outcomes, that means out of the total outcome, there will be a particular events that has to occur. So that is called favorable outcomes of the events. Example, when you toss a coins, the outcome of the sample space that satisfy the events. Example, you want to get a head. Then head is the favorable outcomes of that event. So if the event is getting head when tossing a coins, the favorable outcome is head. Suppose in rolling a die, if the event is of getting even number, suppose even number, what are those even number? 2, 4, and 6. This is called favorable outcome. Now let us go for last one. This is how you have to write in the exam if they ask classical or mathematical or priori definition of probability due to Laplace, then you have to answer like this. Out of n exhaustive, equally, lightly, mutually exclusive outcomes. Don't worry all those words. It means out of total. N means total outcomes. In simple words, out of total outcomes, if M is the favorable outcome, M are the favorable outcome of the event. As an example, we have taken before, out of what? In rolling a die. There are 6 in rolling a die. 1, 2, 3, 4, 5, 6. So that means we have 6 possible outcomes, 6 exhaustive outcome. Then what is the favorable outcomes here? Supposed to get even number. Even number, what are those even number? 6. That means we have 3 even numbers among the outcomes. Then the probabilities of the occurrence of event A. So the event A is to get even number. Let's say the probabilities of occurrence of the even numbers is denoted by P of A. P of A is the ratio. What? The result is the ratio. What kind of ratio? P of A, probabilities of A is equal to M. That is the favorable outcomes divided by total outcome. So this is the ratio we get. And this we can represent as number of outcome favorable to A divided by total numbers of possible outcomes. So this is the definition for probabilities if they ask in exam. Now I would like to tell you here the values of probabilities for any probabilities will be between 0 and 1, and it will be always between 0 and 1. It will not be 2 or minus. It will not have. So what does it means? How to read this? So probabilities of an event A is greater than or equal to 0, but it will be always less than or equal to 1. So now remember, when the probability is 0, when you solve a probability question, if you get 0, then the events will never occur. That means it is an impossible event. When the probability is 1, now when the probability is 1, then the event sure to happen. That means it will definitely happen. Now, this is about probabilities of happening. Let's see the probabilities of not happening. There is a probabilities of not happening. So let's say P bar, probabilities of not happening, is denoted by P bar. So this is P of A bar. You have to put bar. Now, probabilities of not happening of the event A is denoted by P of A bar. Now, how does the definition say so? So, out of n exhaustive outcomes, that means out of total outcome, M is favorable. Here, M is favorable to event A. Then, how to find out which is not favorable to event A? Then you have to subtract n minus M. That means total outcome minus favorable outcome. So here, this probabilities of not happening is given by not favorable outcomes of an event. Not favorable outcome is n minus M. What is the total outcome? Total outcome is n. So we will put here. Then we have n by n minus m by n. We distribute this n for n as well as for m. So n by n is 1. So we have 1 minus m by n. Now tell me 1 is 1 minus. What about m by n? We know that m by n is P of A. So we have P of A. Instead of m by n, we have P of A. Now look nicely how we can solve now. This implies P of A bar plus. If I transfer this towards the other side, it becomes plus P of A equal to 1. This formula is also very important. So note down this formula also. Now we can say that A bar and A are complementary even to each other. So if you get the answer, probabilities of A bar plus probabilities of A equal to 1, then they are called complementary even. Okay, that's all. These are the definition. Please note down in your notebook and then bring it during the class. And if there is any question regarding this probability terms, please let me know. And that's all. So after the festival, after the celebration of Christmas and New Year, I think it will be good for you to focus on your exam again. Your exam is very near. So all the best for your preparation. I know that you guys have a lot of work to do, but I believe that you would be also not forgetting the exam which is knocking at the door. Thank you so much. You all have a great day.